Hello everyone. Welcome to the today's presentation. Today's video presentation is on the used car price prediction model and its potential in the automotive industry. In this video, today I'll be discussing on the key findings and the research uh, project um, which is conducted by me. My name is Varun Kumar Ojha, a student pursuing a master's in data science at LJMU, Liverpool John Moores University. This thesis report is titled as uh, Used Car Price Prediction uh, Using Machine Learning Techniques, which is completed in June 2023. So let's dive in. The research focuses on predicting used car prices using ML, machine learning, enabling informed pricing decision. Um, the driving force was the secondary market for used cars that requires reliable prediction because there has been a lack of research comparing the prediction approaches. The used car market is complex. We had some challenges and it requires uh, accurate pricing methodologies. The study aims to develop a reliable ML model, uh, enhancing decision making in the market. Um, so let's just give you some background. The used car market is a significant global industry, and it has influenced the pricing of the cars. So there is a drastic decrease in the pricing from the new bought cars to the used cars. So transparent and accurate pricing is essential to facilitate the transaction and ensure fair prices between the buyers and sellers. The challenges we faced pricing challenges because the pricing is actually complex. Uh, there are a lot of factors, subjective and objective, uh, which drives the pricing of the cars. And we have used ML techniques to offer a solution by analyzing the data and providing more accurate results. The data um, is um, taken from Kaggle, which is a public data, and it was the same which has been submitted in the research proposal. Um, let's talk about the aim. So the research project is aimed to achieve several objectives, including the development of reliable used car pricing uh, using ML, of course, and exploring the factors impacting the car prices. I have compared machine learning models with traditional techniques also to ensure that we get good results and have accurate prices. Uh, the secondary market for used cars had some gaps, and we happened to study the gaps by addressing uh, the data, and we have also checked the papers cited across the similar areas. So we tried to address the research gap by leveraging this and the potential of ML we have explored. The project aimed to contribute the informed pricing decision. Um, the literature review, let's come to the literature review. The literature review highlighted previous research gaps, which is used in the car pricing. It was found that both ML and statistical modeling approaches can be effectively used to predict the used car prices. Factors like mileage, um, age, brand, engine size, and previous ownership consistently influence the prices. We will see in the results how and what are the major features that has influenced the pricing. However, were still research gaps which we found needs to be addressed uh, in terms of comparing the prediction approaches and achieving optimal uh, precision. So the supervised machine learning techniques and particularly random forest can be seen to predict the prices. Uh, However, its counterpart also performed well, which we will discuss in the result section. The random forest, we saw it performing well in predicting used car prices, uh, but longer training times and alternative encoding methods are required for categorical data. Um, so let's go about the data. The data is a public data, and we have used we have used the design approach for predicting models, and systematic data gathering has been done. We did our cleaning of the data. We did our EDA because there were a lot of uh, anomalies and missing values. We did the exploratory data analysis, and uh, we have cleaned the data properly. And the aims to generate the accurate model were encountered. Data cleaning is necessary. The raw data often comes with a lot of duplicates and missing values, like I mentioned. So the data cleaning and the EDA has been done. Uh, Standard techniques were used, uh, like encoding categorical features, data transformation, dimensionality reduction, and imputation enhancement on the data. Let's talk about feature engineering. Feature engineering proved and played a very critical role in transforming the data uh, into some suitable features for ML algorithms. This is a very good technique. It helps prevent overfitting, and it involves selecting important features, generating the new ones. Scaling and normalizing the data has also helped us. So these techniques enhance the performance and accuracy uh, for my model. Um, so after this, we also did model building. Various machine learning algorithms were used to build the model uh, for the prediction, including linear regression, decision tree, random forest, gradient boosting, and SVR, support vector regression. The performance of each model was compared and has been discussed in the result section. Uh, the results showed that random forest yielded accurate predictions with low MAE, mean absolute error, and the moderate R2 score, R squared, indicating its ability to explain the variance in the target variable. Um, the findings were further analyzed and used using SHAP. Now, SHAP is a technique, shapely adaptive explanation, to identify the most influential features. Uh, I'll discuss more about it. So uh, let's go one by one. Let's start discussing about the results. Before we actually tell the results, let's see the performance comparison. So I would like to have the performance comparison ready. Yeah. So here in our performance comparison, the random forest model performed best among the different machine learning models with a low absolute error and the moderate, I mean, highest R2 score, which is of zero point 0.3, indicating better predictions uh, and the ability of it to explain the variance in the target variable has been achieved. The random forest bagging regressor, uh, an assembled model. Uh, we did the hybrid modeling. Has also performed slightly better than the individual random forest model. And uh, uh, I'll show you the models. So here we can see in the um, yeah. So these were the assembled models. Before going to the assembled models, let's look at the our random forest. So if you look at the actual versus the predicted random forest, see we have the methods perfectly fitting, and this also fit somewhat moderately. And the gradient boosting, its counterpart, also had similar results, and the assembled models were also showing pretty okay. But like I said, the random forest had the uh, low mean absolute error. Um, yeah, so to visualize the effect results effectively, we generated two sharp summary plots. Uh, there's one. Uh, now let's just first talk about SHAP. SHAP is actually used in. It's a popular technique used for predicting and explaining actually the techniques of prediction of the MLs. It provides insights into how each feature contribute to the final prediction. Uh, so we had two plots. The first plot shows, uh, and it's actually providing an overview of the feature importance by displaying the distribution of the SHAP values for each feature. If you look carefully, the manufacturer, car, and the kilometers driven were the most influential features. This plot helped us to identify the feature that exerted the most significant influence. Uh, yeah, and similarly, we had the second plot. Um, it's from the same SHAP. Uh, it gives a more clear picture in the bar presentation. So this visualization allowed for a straightforward comparison between the features. The taller the bar, indicating the greater influence of the prediction. So we employed SHAP and to understand the feature significance, and um, SHAP values were computed, and yeah, this enhanced the interpretability and transparency of the models. Um, I have kept linear regression, random forest, and random forest bagging regressor, the counterpart of the random forest, which performed almost similar. And um, in the summary, I would like to say among the models evaluated, random forest model and its assembled counterpart, random forest bagging regressor, um, showed most promising performance, and we were actually able to achieve our results the way we expected. Some of the models did poorly performed, and yeah, um, that's uh, the major uh, promising uh, models. So let's talk about the conclusion and future recommendations. In the conclusion, uh, the research project successfully achieved its objective. I would like to bring back the objective. The objective was to uh, predict the prices of the used car, which is actually a complex market. This secondary market requires a lot of uh, training of the model, training of the data, because the market is complex and there is a huge difference in the pricing uh, factors and the parameters when compared to the new bought cars and the used cars. So yeah, our model performed well. The findings can enable informed decision and operational optimization in the automotive industry. This can also help uh, in the future research work and can focus on exploring the advanced assembled techniques, integrating domain specific features um, like light GBM and XG boost. We want GPS, fuel, and efficiency to also to be considered. Uh, we can leverage and bring in more data uh, based on our research. That could be our future work. So um, the findings that we had um, were seem to be promising. The highlighted importance uh, of advanced analytics for accurate car pricing prediction was somewhat achieved, uh, and the future recommendations have been given. Um, these areas can also contribute in improving car pricing, uh, benefit stakeholders, and both it is both good for the buyers and the sellers. Uh, that's my future recommendation. Um, so I would, in the end, I would like to thank you for watching today's video presentation on used car price prediction using ML techniques. My name is Varun Kumar Oja, uh, and this research uh, thesis uh, was done for the Masters in Data Science. And our research project provides valuable insights into the potential of ML in the automotive industry. Thank you again. Thank you for staying till the end. Bye.